AlphaKoala here again. Gonna go over the second question, which I found a lot of people were struggling with. Probably the question most people struggle with. Now, the question reads, a jetliner with an airspeed of 1,000 kilometers per hour, so we'll put that in, its initial velocity is 1,000 kilometers per hour, sets out on a 1,600 kilometer flight due south. So I've put my little thing in there. South is going to be that direction, east, west, and north, for the purpose of this question. I'll also define my x and y axes now. So x and y, that will be positive x, and that will be positive y. That's the general convention. To maintain its southward direction, so it's trying to fly 1,600 kilometers directly south, right? That's how far it's going to go, and it's going to be directly south when all is said and done. To maintain this direction, however, the plane must be pointed 15 degrees west of south, which is going to look like this. 15 degrees west of south. That's going to be my south, that's going to be my west. Now, because the answer asks for it to be in kilometers per hour, I'm going to leave everything in kilometers per hour throughout the question. So we'll put that as 1,000. Alright. Now the first thing we're going to want to do is break its initial speed into two vectors. One vector for the x-axis and one vector for the y-axis. Note that if the positive x-axis is that way, and the plane's x-axis is going to be this way, it's going to have a negative magnitude along the x-axis. The same goes for y. If positive y is that way, then if the plane's going down this way, which is south, then it's going to have a negative y direction. So if I just grab my calculator, alright, to work out this is the opposite side in relation to this angle. This is a right angle. So the opposite to this angle is going to be, it's x direction. So to work out opposite, we go opposite equals the hypotenuse, which is this value here, times sine theta, and theta will be the angle, which is going to equal 1,000 times sine 15 degrees, which is going to equal 258.82. And since we said that it was going to be negative, we'll just put a little negative sign right in there like that. As for the adjacent, it's going to be the same thing, but with the cos, so it's going to equal hypotenuse, which is 1,000, times cos 15 degrees, which is going to equal 965.93. And once again, since it's negative, we'll pop that little negative sign in there. So that's its initial velocity. So we'll put that in to a little form. Okay, so that's its initial velocity in kilometers per hour. So the next thing we're going to do, because we want to work out what the wind's velocity is. The first thing, we'll draw a diagram. We'll draw a diagram to help everyone imagine it. Okay, so we have its initial velocity, 3,000. We're going to have the wind's velocity, and then we're going to have its total velocity. Now, since this is just vector addition, we know the plane's velocity plus the wind's velocity will equal the resultant velocity. Now, we don't have the wind's velocity, so we can't work that out yet. So what we're going to need to do is rearrange for the wind's velocity. So the wind's velocity will equal the resultant subtract the plane's velocity. And, that's just moving the plane to the other side. Now, we do know the resultant velocity, because we were given the distance it travels, and in the question we're given the time. Time will equal 120 minutes, which we can divide by 60. We'll put that in. We'll give 2 hours. Yeah. And, that's just converting units. You should all know how to do that by yourself by now. So the final velocity, we know, since it hasn't gone sideways or anything, the final velocity is going to be directly south. Because if it had a horizontal resultant velocity, it would be out here somewhere or out here somewhere. Because it's gone directly south, we know that the velocity will have to be directly south. And velocity equals the change in distance, or the change in displacement, over the time. And that's going to be hours, it's going to be kilometers. It's going to be kilometers. And that's going to equal 800 kilometers per hour. So that's its final velocity. And once again, it's got no horizontal velocity because it's gone directly south. So we can write that in as 800. Now, if the wind's velocity is equal to the resultant takes the plane's, all we have to do is go 0, the resultant's horizontal velocity, take negative 258.82, which is the plane's initial horizontal velocity. And we'll just rub this line out here, because I'm going to run out of room. And the vertical final velocity, sorry, that should be negative, because we know it's gone south, so it's going to have a negative velocity, which would be negative 800 subtract negative 965.93. And that's going to give you your wind's velocity, so its directions, which is all we want. We want the wind's velocity in Cartesian form. So 0 minus negative is going to give plus 258.82, and negative 800 plus 965 is going to give plus 165.95. Now, we want to round to two significant digits. I'm pretty sure that's what the question asked for. Yes, it did. Okay, so this to two significant digits, they are my significant digits. 260, this to two significant digits. This is going to round to a 6, this is going to round that to a 7. So it's going to be 170. And that will be the velocity of the wind. Which means the wind was in fact not going that way because it had a positive y direction. So if we redraw this, I'll grab the cloth quickly. If we redraw this a little more accurately, we'll find that the downwards velocity was actually less than its intended velocity. And the wind's velocity was, 170 upwards and 260 across. And that will give you your answer. So hopefully that should kind of explain what's happened. Not sure if it was really clear. Basically, broke the initial velocity into vectors to get my initial velocity, which was, we know that the plane's velocity plus the wind's velocity is going to equal the resultant. We've already got the plane's velocity broken up. We know that if we rearrange this, we can find the wind's velocity equals the resultant, take the plane's. We know that it travels 1,600 kilometers 2 hours, so we know its resultant velocity, so we can just work that out by dividing that, taking that old 800 kilometers per hour. Then we just get the resultant velocity, subtract the plane's velocity. Now the reason we've done it like this is you can only take x values from x values and y values from y values. Often you'll find they're called i's and j's, and those are standard vectors. You're going to have to probably read up on those because those are actually pretty important. But, I'll probably introduce them and use them more next question. This was kind of just to give everyone a feel for how the question goes. Now, once we've got that, we can take resultant from planes that will equal the wind's velocity, round to significant figures, and that should be your answer.